Hi everyone, myself Zion Goldman. So today I'll be giving a brief description on industrial automation. So let's come to the term automation. By definition, we can say that automation is the process by which we can control any machine or a process that can be automated. That means, for example, when you're coming home from a hectic day of work, you have to turn the lights on, you have to turn the AC on, but you are not in a mood to go there and switch on the lights. So what you do is you place a sensor inside your home which will automatically actuate when you enter. That means the equipments or the electrical gadgets that will be turned on. Similarly, in an industry, when you consider the machine, or else we can take an example of a conveyor. So here, what happens is this conveyor will be running and each of the products will be coming in line. So now a process has to be taken place. What you can do is you can fix up some instruments there and you can connect this to your remote terminal unit. So here today we will be discussing all these things, and let's go to the first part. Now let's come to the history of automation. So the history of automation, it can be classified into different stages. The first one is manual system. So in manual system, the manpower was used. Now this is not possible for all the processes. Like we cannot introduce a person to do all the job. The accuracy, the precision, that won't be there. So what we did was we came to the next one, that is the pneumatic and the hydraulic system, that is using water and air. Now the major disadvantage is that we cannot control an output which is far away from the input, or there is a limit. So what we did was we introduced the hardware system. That was the next stage. In the hardware system, the major disadvantage, that was the troubleshooting was not at all easy. Now imagine a big process and we have a lot of wires embedded in their room. What we can do is we have to identify each of the wires for a troubleshooting purpose. Now this will take a lot of time, and this was not at all easy. So what we did was we embedded all these things in a chip called IC, or integrated circuits. Now these ICs, which comes under the electronic system. So that means these ICs were embedded and these all formed a microcontroller. Now coming to the disadvantage of this microcontroller, this cannot be used in an industry. Why? Because it cannot withstand the vibration, the temperature or the pressure in an industry. Now for this, what we did was we went to the next stage, that is the introduction of PLCs. It is PLC which can be simply said as a programmable logical controller. Inside the PLC, the microcontroller will be there. So it will be controlling the logic and the casing the PLC has. That will be withstanding this vibration, the temperature and pressure. Now this was suitable for the industry. Now again, technology has to advance, and we are in the technology or the future technology, that what we are using is ABCD. We can define as ABCD. A for artificial intelligence, B for big data, C for cloud computing, and D for digital marketing. Again, we have a number of technologies and we will be concentrating on that. But here today in industrial automation side, what we are mainly focusing is the PLCs. So we will be learning all the hardware, the software, the wiring side of the PLCs, and we will be continuing that. Now let's see the application of automation. See, automation can be seen everywhere. Now if you need to automate your home, you can go for home automation. And if you need to automate an industry, there is industrial automation. Now coming to the pharmaceutical side, there is also automation. Now coming to the automotive side, like you need to design, assemble an engine, automation can be used. The assembly line, it is fully automated now. So again, coming to the marine side, if you need to automate the engine of a ship, means you can go for automation. Yes, there are a number of applications that you can do with automation. So automation is the future, and let's learn the tools of automation. So basically there are 4 different tools for automation. The first one is PLC, or a programmable logic controller. Here, as the name implies, it's a logic controller and we have to program that. We are dumping a program to the logic controller and our inputs and the outputs will work accordingly. Now coming to the next one, that is SCADA system. SCADA stands for supervisory control and data acquisition. You can have the overall control over an industry or a process plant. Now the data acquisition, you can get the values from the field. So overall, you have the entire control over the inputs and the outputs. So likewise, it can be also said as a tool for automation. Now the third one, that is VFD. You might be familiar with the term VFD, that is variable frequency drive. So variable frequency drive, it is exactly used to control the speed, the rotation and the direction of a motor. So we'll be learning VFDs, the configuration, all those stuffs will be coming under that. And the final one, that is HMI, or human machine interface. See, it works as an operator panel. For example, now you go to an ATM, you just give the touch screen, all these things, you just give a touch and the process is done. Similar to that, we will be learning how an HMI works or how it is used for an industry. Now let's discuss on automation pyramid. So in an automation pyramid, we can see different layers. So the first layer is the field level, the second one will be the control level, third one will be the supervisory level, the fourth one the planning level, and the fifth one, that is the management level. So let's take the case of each of these layers. The first one will be the field system or the field level. So here what we can see is the physical work is done by the field instruments. For example, the actuators, the sensors, all these things will be working. And here the field level comprises of all these field instruments. Now coming to the second level, that is the control level. See, the field instruments, they are connected to these control elements. For example, a PLC or a programmable logic controller. Now in case if you want to take a case of PID also, that will be also coming under this level. Now coming to the third level, which is the supervisory level. That means here the monitoring is achieved, which means SCADA system will be coming under this level. SCADA system can monitor the entire process happening in an industry. Unlike the HMI or the PLC monitoring with a single device, this SCADA system will be monitoring the entire process. The fourth level of the automation pyramid is the planning level. Here, it utilizes a computer management system known as MES or manufacturing execution system. Now, the persons or the management persons, they can monitor all the processes happening in an industry. So therefore, they can estimate the raw materials needed for the production. The top level is the management level. The management level, it utilizes the company's integrated management system known as ERP or Enterprise Resource Planning. So the ERP, it is a combination of different computer applications which is used to monitor the each and every process happening in a company. Now, using this, the business can monitor the different operations which is happening. For example, from the manufacturing to the sales to the purchase and so on. So now we have seen all the different levels of the automation pyramid. Now let's go to the next topic. Now let's see the architecture of a PLC. The PLC mainly comprises of the input cards, the output cards, the power supply, the CPU, the memory, the communication ports, and the isolation barriers. So here we'll be seeing each and every part deeply. Now let's go to the first one, that is the power supply. So the power supply, based on the power supply, the PLC can be classified into AC type and DC type. So here, if you are able to give the 230 volt to the PLC, that means it is a AC type PLC. If you are giving the 24 volt DC, that means it is a DC type. Now, how can we classify this? So basically, we have to convert. The PLC will be operating in a 24 volt DC voltage, right? So now we have to convert the 230 volt AC to the 24 volt DC. Here we use a device known as SMPS or switch mode power supply. So now let's see the major components of an SMPS. Now we have to step down the voltage from 230 volt to 24 volt. So here the major component is a step down transformer. By using the step down transformer, 230 volt is converted to 24 volt. Now we have to convert the AC to the DC. Here we use a rectifier. So what happens is, with the use of rectifier, the AC is converted to DC. Now there will be some ripple factors. To eliminate these, we use a filter. So with the help of filter, this 230 volt AC is converted to pure 24 volt DC. Now the voltage has to be regulated. Here we use a regulator. So these are the major components of an SMPS. Now the external SMPS is used to supply the 24 volt DC to the PLC. Now in case of AC type PLCs, the SMPS kind of arrangement will be seen below the PLC. So what we have said is we have two types of PLCs, that is the AC type and the DC type. So with SMPS means it is a AC type, and without SMPS that is a DC type. That is with the case of power supply. Now let's see the case of the input cards and the output cards. In a PLC, there are two types of inputs and two types of outputs. So basically it is classified as digital inputs and digital outputs, and analog inputs and analog outputs. So for example, we can take the case of a push button or a proximity switch for the digital input. Now for the digital output, you can take the case of a solenoid valve. Now coming to the analog input means the values will be varying. So here we can take the case of a level transmitter, or you can take the case of a ultrasonic sensor. Now to the analog output side, you can take an example of a simple control valve. So here normally the analog value, it will be in the form of 4 to 20 milliamps. So basically we will be learning all these in detail in the next topics. Now let's see the case of CPU, or a central processing unit, like what we say as the brain of a computer. Similarly, the PLC CPU, it processes all the instructions. For example, we will be having a number of instructions inside a PLC. So likewise, there will be arithmetic logic unit for processing the arithmetic operations, such as simply the mathematical operations known as addition, subtraction, multiplication and division. Similarly, there are other instructions also, which will be the timers, counters and all the basic instructions that will be covering up in the next topics. And again, coming to the memory. So the memory, basically we can say there are two types, that is RAM and ROM, which is the random access memory, and the second one is the read-only memory. So the in PLC we can say it as the processing memory and the data memory. So this will be the memory part of a PLC. Now let's come to the communication part of a PLC. In order to communicate with the external devices or to program the PLC, the communication is really important. So here we make use of different communication protocols. The protocols might change according to the manufacturer. So we have to know each and every protocol in detail. Here we will be basically concentrating on the Modbus protocol, the host link protocol, DF1, the Profibus, etc. So we will be learning all these communication protocol in the coming up sessions. So right now I'll be explaining about some of the communication ports. So the communication ports in a device means, now we have to communicate with an external device. We have to have a port there. The wired connection should be done perfectly. So the basic communication ports, the first one is Minidin 8, or basically we call it as MD8, which comprises of 8 pins, and it was used before. Both the RS-232 and the RS-485 standards are used here. Now the second one, that is DB9, or we call it as data sub miniature 9. Here we make use of the 9-pin port here. The communication is achieved successfully using the RS-232 or the 485 standard here. The third one, which is widely used now, that is known as the Ethernet port, or we call it as the RJ45 port. Now the transmission is very easy and it is very fast inside the Ethernet. So the next part, that will be the USB protocol. You all might be familiar with that. So it is normally, the protocol is the USB. The port we are using will be the USB port. So that is with the communication ports and the protocols of a PLC. We will be looking into this deeply in the next sessions. Now let's see the case of isolation barriers. Basically, the isolation barrier, it is used to protect the CPU from overvoltage from the input cards. Like if you are having an overvoltage from the input field device, it won't be affecting the CPU because of this isolation barriers. Basically, we use two types of isolation barriers. The first one is optocouplers and the second one is relay type. So optocoupler is basically an arrangement of a diode and a transistor. Like what it means is the electric signal, it will be converted into photo signal which won't be directly given to the transistor. So the signal will be actuated or the transistor will be actuated, but there is a gap in between the diode and the transistor. Likewise, the diode will be damaged if there is a over voltage, not the CPU. So that is the case with the first segment or the optocoupler. Now let's come to the relay case. We know what a relay is and how the relay works. So basically in the output side, we will be using a relay switching mechanism. Here, another types of mechanisms are the transistor type and the triac type. But the thing is, the relay can switch both AC and DC. The transistor, which can only switch DC type, and the triac, which will only switch AC type. Now let's see the programming languages used in a PLC. So in order to program a PLC, we can use a number of programming languages. Here we will be seeing the main languages used to program the PLC. The first one is ladder diagram. So basically it is the most widely used language. So in any industry, if you go there, you can see the PLC working under this ladder logic. It is a combination of different symbols. Now the second one, that is functional block diagram. When you take the case of a Siemens PLC, you can see the widely used one is FBD or functional blocks. Here, for example, if you want to add some values, there will be a block called the add block. You will be giving some inputs and the output will be the added value of this. Now let's see the third one, that is instruction list. So for example, when you are programming a microcontroller, you will be using some different instructions, right? Similar to what you can say as a MOV for the move, so SUV for the subtraction, all those things. So these instructions, likewise you can use these instructions to program a PLC, and this is basically called the instruction list programming type. Now the fourth one, that is the sequential flowchart. So basically you know what a flowchart is. Here we will be defining all the conditions in the form of a flowchart. We can give the conditions, and if the condition is perfect, means it will go to the next one, or else it will end there. So that is the case with the flowchart. You can see the image on my right side. So the next one, that is structured text language. So here it is basically similar to a coding C. That means you can write the conditions, you can explain the conditions in a structured text way. That is, you can give the condition like, for example, if x equal to 1, then your output y equal to 1. Likewise, you will be scripting. So all these languages are used to program the PLC. We will be using the ladder logic for the wider range and FBD also. Now, when you consider programming a PLC, the most easiest and comfortable way is with the ladder logic. So in a ladder logic, we have certain elements to look out. So I'll be explaining the different elements. Okay. So you see the two vertical lines, those are called rails. In plural, those are called rails. Singular, you can call it as a rail. So the horizontal line, the next one is a horizontal line, which we call as rungs. So be clear, rungs and rails, they form the ladder logic. So these two things are really important. You have to know the names. Now you will be placing your contacts in the rung only. Likewise, you can see a end rung. In every PLC, there will be an end rung. Okay. So we can add the new rung and we can place the contacts in those rungs. So this is how a ladder logic works. As I explained, the rails are there, the rungs are there, and we will be placing our input and output contacts in the rungs. So this is the case with the ladder design. Now I have said that we have to place the contacts in the rungs, right? So basically we have two main contacts, that is the NO contact and the second one is the NC contact. NO stands for normally open and NC stands for normally closed, and the output coil. Okay, let's see how an NO works. So normally open, it is initially in the open state. The circuit is not closed. So when we turn on or energize the coil means the circuit will be closed. So basically in discrete values, what we can say is the normal value will be 0 for the NO. If it is energized, the value will be changing to 1. Now coming to the case of NC. So it is a normally closed circuit. Now what happens is it is already energized. If you are planning to turn on or energize the coil, means this NC will be turned off or it will be changing to the value 0. So basically the NC, the initial value will be 1, and if we turn on or energize, the value will be changed to 0. So that is the case with NO and NC. So like I said, these things should be placed on the extreme left side. That means the NO and NC contacts, it can be placed on the extreme left side of the run. Now the output coil should be always in the right side of the run. So this is how you place the input and the output contacts. So now let's check the scan cycle of a PLC. Now there are 5 different steps in a scan cycle. So let's go to the first one, that is the CPU check. So the CPU check means the CPU will be checking which state the PLC is. That if it is in run mode or the stop mode, or if there is any fault in the PLC. So after confirming all that, it will be going to the next step. That is the input-output module check, which means it will be checking the modules which is connected with the PLC. So after confirming that, the next stage, that will be the checking of input modules or the updation of the inputs. Now here, what happens is the PLC, it will be scanning all the inputs which is connected with the PLC. Now what happens is, after the scanning, the program should be executed. That is our next step. So that means execution of program will be coming as the fourth step. So now as per our program or the program we have dumped to the PLC, the output should be updated. That is the fifth step. Now the outputs are updated and our PLC program will be running successfully. Now let's see the rules for constructing a ladder diagram. So the first rule, that is the inputs, that is the NO and NC contacts, they should be placed on the extreme left side of the run. Now the outputs, they should be placed on the right side. So this is the first rule. Now coming to the second one. The second rule is that the inputs can be placed in series or parallel or as a combination of series and parallel. Whereas the output, it should be only placed in parallel. Now coming to the third one, that is the inputs or the input address, that can be repeated any number of times. But in case of output, the address should not be repeated. Now the final rule, that is the output can be repeated but on the input side. So when you are writing a PLC program, the address from the output, that can be taken on the input side or for the input contacts. So these 4 are the major rules of constructing a ladder logic. Now to give you an idea of how a PLC works and how it can be interconnected with the factory terms, I'll give you a sample program, and here we'll be using 2 different softwares, one of the PLC software and one is known as the factory IO. So it is a sandbox. Now we'll be doing a simple program like the movement of a conveyor. Let's check how it works. In this course, we'll be seeing 2 softwares. One is factory IO and the second one is TIA portal. So factory IO, it is basically used to design our industry so that it can be said as an automation sandbox. Now to program, we need another software. There we'll be using the TIA portal. This will be used to program our particular PLC. Now let's see how to design using factory IO. So I'll be opening that first. So here we will be creating a new file. For that, click on new and this will be our workspace. So here you can navigate as you need, and on the right side you can see the objects. Those objects we will be using for designing our factory. So here I'll be taking the case of a simple conveyor belt. For that, I'll be taking a 6-meter conveyor. I'll be dragging it to here so that my conveyor is placed. you can see a motor is attached below that conveyor. Now what I'm gonna do is, I have to place a object in the conveyor. For that, I'll be taking a box, the normal one, so that I'll be placing and fixing it here. Now we have placed the box successfully. As my conveyor moves, the product will be moving through the conveyor. Now to turn it on, I need a start push button. Yes. So this will be the total length of the conveyor. The product will be moving from this end to that end. Now to place a control panel, I'll be using a column. For that, I'm taking this column here, placing it here. Now to place a control panel, so I'll be using a normal electrical switchboard. I'll be dragging it here. Now that we have placed the control panel, what we have to do is, we have to place the start and stop push buttons. So that if I press the start push button, the conveyor will start moving. That means the motor will start running. Yes, to place that, I'll be taking the start push button. Now again, I have to place a stop push button, so that I have to stop the conveyor. Yes. So you can see here in the electrical switchboard, the start button and the stop button is successfully placed. Yes. We have to arrange all that, so that when I press the start button, the conveyor will start moving. Yes. So this is our entire workspace. Now let's see how to configure the program. Yes. Now let's see how this works. So to create a new project, I'll be clicking on create new project. Here I'll be giving a project name. So I'll be naming it as communication with FIO, which means factory IO. Then I'll be clicking on create. Now the first step is to configure a device. That means we have a PLC here and it is connected via Ethernet. So I have to configure the device. For that, I'll be clicking on configure a device. See, to add a new device, you can click here on the add new device and a window will pop up. So here our controller is S7200. So I'll be clicking on that. Here I have to select the CPU model, which can be normally seen on the PLC on the right side. Here my CPU is 1212 DC bar DC bar DC. And here my CPU model number, that will be 6ES7-212-1A-E400XB0. Here I have my controller shown here. Now I will just go down and add this device. Now to program our PLC, what we have to do is, we have to go to the programming blocks. Here you can see the program blocks. There will be a drop down menu. Here I will be clicking on the main block, that is main OB1, operation block 1. Now as you have learned in the introduction, you can see the normally open input, normally close one and the output. So we will be making a simple latching circuit here. Now for that, I will be clicking on the network, placing my normally open. Again, I will be placing an output. Now to latch this, I will be doing a rung branch here. So I will be clicking here, clicking on the rung branch and placing my another normally open contact. Now I have to connect this. Yes, it is successfully done. Now to place an NC, that is for the stop push button, I will be clicking here and I will be clicking on the NC. And again, I will be giving the address, that is %I0.1. Now to download this to the device, I will be clicking on download. Now we have successfully downloaded the program to our PLC. Now to go to online mode, I will be clicking on this option, that is monitoring on or off. Now our PLC is in monitoring mode. That means if I turn on my first input, my output will be turned on. So now let's communicate this with the factory IO. I'll be going to factory IO, and here we have previously designed all the things we need. So here is the conveyor, the box and the control box. Now to communicate with the PLC, what I'm going to do is I'm going to File and I'm going to Drivers option. So when I click on Drivers, here I can select the driver. So my PLC is S7200 and you have option available here. Now what I'm going to do is I have to place the start and stop button. So I'll be taking the start button, dragging it to the first input, stop button to the second input, and the roller conveyor, that is our output, that will be on the first output. Yes. Now that's completed. Let's try to connect with the PLC. Yes, it is successfully connected. Now let's see if it is successfully working. Let's go back to the Factory IO workstation. In order to run this process, there will be a play button on the top screen, that is switch between edit and run mode. You can click on that. Yes, now it is in the run mode. Now if I press this button, the conveyor should run, and if I press this button or the stop button, it should stop. Yes, now let's see how this is communicated. So I'll be giving the screens parallelly. Now if I press the start button, the conveyor should be moving. Now let's see if it is happening. Yes, our program is successfully compiled. To stop, I will be pressing the stop push button. Yes. So this is how we communicate the Factory IO sandbox with Siemens S7200 PLC. So let's see some of the industrial process now. I'll be taking you to a walk. We'll be analyzing some of the process. So let's go. So this is a sorting station and you can see the main conveyor here and you can see the drawers. So what we do here is the objects are sorted according to their size. We'll be deeply learning all these. So now let's go to the next process. So here you can see a oil level controller. And here we will be controlling the level of the oil. So we will be learning how to program this one, how to simulate it on Factory IO, and we will be learning the other processes also. So let's go to the next one. So here you can see a robotic arm, and this robotic arm will be doing all the processes, or it will be sorting it out. So we will be learning this one also and many more. So goodbye for now. Anyway, we'll meet soon again. We will be learning a lot of things in industrial automation. Thank you.